This is for Connie, because she's at some show or something. This is wave basics. So you have a transverse wave and you have a longitudinal wave. Transverse wave, the oscillation is perpendicular to the propagation, and a longitudinal wave is parallel to the propagation. This is a diagram of a wave. So the highest part is the crest, the lowest part is the trough. The amplitude is from rest to crest, and the wavelength is from one part of the wave to the same part of the wave. If you wanted to measure the energy, you could calculate the mass of this, get the potential energy and also the speed, and then you can calculate the energy. I'm not going to ask you to do that, but that's why we care about the rest instead of the whole thing. Here, Jack. Best of luck. Have fun. Question. Does a wave have a velocity?
Yes.
Yes. If you want to change the velocity of a wave, what must you do?
Change the wavelength.
Nope.
Change the thing that's going through.
Brianna?
Change the thing that it's going through.
Give her a golf clap. What do we call the stuff the wave is going through?
Medium.
The medium. So you must change the medium in order to change the velocity. Now, imagine you are all standing on a pier. We'll do this one day. I'll take you down to the beach and we'll stand on the pier at John Lawson. And let's imagine there's waves coming at you and they're going past you. And does anybody here have a tape measure in their pocket? No? You guys don't do that?
I usually carry one like a 6-foot one.
Really?
Yeah.
I wish you had it here. That would have been awesome. I carry one in the side door of my truck, always. It's very handy. It's surprising how often you need it. If you had a tape measure, you could measure from one crest of the wave to the next crest of the wave, and that would tell you what?
Wavelength.
The wavelength. Let's say we count. We have a stopwatch. And we count for 10 seconds, and we count 30 waves go by in that time. If you count 30 waves in 10 seconds, how many waves are going by per second? 3. If each wave is 2 meters, and 3 of them go by in 1 second, what is the speed of that wave?
6.
Good. 2 meter waves, 3 of them, make 6 meters in 1 second.
So the formula is what? Lambda?
Get it? Let me draw. We're standing here on the pier. And you have the wave going by you. And this is, oh, I need one more. This is 2 meters. Okay? And you time it, and this one went by you 1 second ago. So you have 2, 4, 6 meters go past in 1 second. So the velocity of this wave would be
3 meters.
6 meters per second. You understand? That would be a really fast water wave. It would be like that. And it'd be really fast. It would be a bad storm. But you get the idea. The formula for that is called the universal wave equation. I've shown it to you before, but V equals lambda f. Velocity is wavelength times frequency. What if you don't have frequency, you just have the time it takes for one wave to go by? What do we call that? Say it again?
Frequency.
Close. The frequency is how many waves per second. The time for one wave, we call the period. And we say it's big T. And the period is a reciprocal of the frequency.
Wait, what is T?
Period.
Period of what?
The period is the time for one wavelength.
Is 1 over the frequency?
Yep.
Is there an inverse equation or no?
No, not really. The period is the time for one wavelength to pass. So, wait for me to write it down. Let's say we're standing on the pier and you have a stopwatch and a wave goes past you and it takes 1/4 of a second to pass. You're like, if one wave takes 1/4 of a second to pass, then how many waves do you get in 1 second?
4.
4. Inverse. So if your frequency is 4 waves per second, that means the period, the time for one wave, is 1/4. So what if you had 60 waves per second? What's the time period for one wave?
1 second.
1 over 60.
1 over 60. 1/60th. So if you look up at those lights there, the fluorescent ones are kind of weird, but these lights are on a circuit of 60 hertz. So the current is going forward and backward 60 times every second. That's about 1 second. Can you tap your finger 60 times in that time? I'll snap my fingers, you tap as many as you can. Ready? It's good, I think. I had a friend who could play Galaga like that. Back in the day when we do you guys know about arcades? We used to play video games. We used to have to like go to the arcade with quarters in your pocket. You have a big thing of quarters in your pocket, and you'd be like, you'd go up to the big machine and you'd be like, plug in a quarter, and you'd be like, and be like, you get to like, it was good to be honest. Anyway, these lights have power going through at 60 hertz per second. So every second, you get it back and forth. It's like, we can't see it because human eyes can only see about 10 changes per second. A fly can see about 10,000 changes per second. So a fly can see this blinking, but we cannot. Period and frequency reciprocal of each other. So if you change this, what's the F going to equal here? What could it equal if you wanted it to?
If you change what?
If you use this and put it in here, how could you change this equation?
1 over T.
Good. So V is lambda F. It can also be lambda over T, which kind of makes sense. Meters per seconds, right? Just the thing. Brian's thinking of that. So that's waves. Reflection. Let's talk about reflection. There's 2 angles involved in reflection. What are they?
Incident and reflection.
Angle of incidence, angle of reflection. What would you say about those 2 angles? They're equal. So how much of a mirror do you need to see your whole self? Half. Only half. Because the light from your feet goes up to the mirror and comes back to you. And that point will be about halfway up. So you only need half the mirror. I just drew R2D2 in here for some reason. This is the normal line. We always measure the angles from the normal line. What does normal mean?
Perpendicular.
Good. Perpendicular. Okay. Last thing is refraction. What is refraction? Rodian.
I guess light passes through, but the speed is slower.
Okay, good. So light passes into a different medium. What happens to its speed? Changes. If it's more dense, if it's going into more dense, it slows down. If it's less dense, it speeds up. Put your arm like this. This is the surface. Here comes a light ray. If it's going into more dense, what's it gonna do? It's gonna bend down towards the normal. What if it comes down and goes into less dense? Then it's gonna speed up and it's gonna bend away from the normal. That's the equation we use for that, right?
Snell's law.
Snell's law. What are the ends for?
The refractive index.
Refractive index of
The median.
Medium.
the medium. So if it's coming from this medium, this is N1. And if it's going into the one in the bottom, that's N2. You guys all know how to do signs and stuff, right?
Yeah.
N, if you have to find the N, you do the speed of light divided by the speed in the medium. So this is this always more than 1 or less than 1? What's bigger, the speed of light or the speed that light travels?
Speed of light.
Speed of light's always bigger. So is this more than 1 or less than 1?
More than 1.
Always more than 1. N is always bigger. And the bigger the N, the more light is slowing down in that substance. How you feeling, Mike?
Good.
Good?
Wait, is there any formula for the reflection or no?
Not really. Just theta I equals theta reflection. I put my phone down.
Wait, what is
I was like, where's my
frequency again?
phone?
What is frequency?
That was for you, Connie. You had a good show.
You asked what frequency is.
What is frequency?
How many waves is there?
Yeah, frequency is the number of waves that go by per second. What is the unit of frequency?
Hertz.
Hertz. Very good. Let's just write that.
The car rental company.
It is. Number of waves per second, and the unit is hertz. So hertz is cycles per second or waves per second, oscillations per second, whatever you want.
Why do you have an L on your board?
What else?
Yeah.
Oh, because we're all learners.